Hey everyone, welcome back to BugNoJutsu. In this video, we're going to solve an exciting matrix problem from LeetCode 3446. Sort matrix by diagonals. This one is particularly fun because it doesn't just ask us to sort diagonals in one way, it gives us two different rules, depending on whether the diagonal belongs to the top right or the bottom left part of the matrix. This forces us to think carefully about diagonal traversal and apply sorting in a very controlled way. By the end of this video, you'll have a crystal clear understanding of how to approach and solve this kind of problem. We're given a square matrix of integers, and our task is to sort its diagonals with two conditions. The diagonals that belong to the bottom left half of the matrix, including the main diagonal, need to be sorted in non-increasing order, that means descending order. Meanwhile, the diagonals that belong to the top right half of the matrix should be sorted in non-decreasing order, that means ascending order. So in short, depending on where the diagonal starts, we apply a different sorting direction. This dual requirement is what makes the problem interesting. It's not enough to just process every diagonal the same way, we need to clearly distinguish between the two halves of the matrix and apply the right sorting rule. Let's look at a simple example to understand. Suppose the input matrix. If we focus on the top right diagonals, like the one starting at 0, 1, we collect the numbers 7, 2. Sorting them in ascending order gives 2, 7, which we then put back. Similarly, for the diagonal starting at 0, 2, the numbers 3 remain unchanged since it's just one element. Now let's move to the bottom left half. For the diagonal starting at 0, 0, we collect 1, 8, 6, and sorting them in descending order gives 8, 6, 1. For the diagonal starting at 1, 0, we collect 9, 5, and sort it into 9, 5, since it's already in descending order. Finally, the diagonal starting at 2, 0, is just 4. After placing everything back, the final matrix becomes that's exactly what the problem asked us to achieve. The way we solve this problem is by breaking it down into two clear parts. First, we handle the upper diagonals. These are the diagonals that start from the top row but not the very first element. For each diagonal, we collect its elements one by moving down and to the right until we run out of rows or columns. We store them temporarily in a list, sort them in ascending order, and then place them back into the diagonal positions. Once we've handled the upper diagonals, we move on to the lower diagonals, which include the main diagonal as well. For these, the process is exactly the same, collect the diagonal elements into a list, sort them, but this time in descending order, and then put them back. By following this systematic approach of collect, sort, and place back for both halves of the matrix, we guarantee that all diagonals are sorted according to the rules. Believe it or not, diagonal traversals like this are used in image processing and matrix transformations, where pixels along diagonals need to be adjusted together. So, problems like this aren't just puzzles, they connect to real-world computational tasks. Now let's talk about complexity. Each diagonal can be at most n elements long in an nxn matrix. Sorting one diagonal takes k log k, where k is the diagonal length. Since there are about 2n1 diagonals overall, the total time complexity becomes n square log n, in the worst case. As for space, at any given time we're only storing one diagonal in a temporary list, so the space complexity is n. The biggest insight here is to realize that instead of struggling to manipulate diagonals directly inside the matrix, it's much easier to extract them into a temporary list, sort them, and then write them back. This keeps the logic simple and clear. Another important insight is to carefully separate the problem into two parts, the upper diagonals and the lower diagonals, because the sorting order is different. Once you make that distinction, the implementation becomes straightforward. This approach also shows how powerful it can be to break down a problem into smaller, well-defined subproblems. And that wraps it up for today's problem, 3446. Sort matrix by diagonals. We understood the rules, walked through an example, explained the solution step by step, analyzed its complexity, and shared some key insights. If you enjoyed this breakdown and want to see more detailed problem explanations, don't forget to like the video, subscribe to BugNoJutsu, and hit the bell icon so you don't miss the next one. Thanks for watching, and I'll see you in the next video.